maybe some more people will filter in, but we'll go ahead and get started, I think. Welcome everyone to part 3 of this workshop. This is led by Jessie Kendall-Bar. I'm going to keep the introduction brief because most of you have probably already heard it. But Jessie is a PhD candidate here at UC Santa Cruz in the EEB department in the Costa and Williams labs. She studies marine mammal physiology and neuroscience, specifically looking at sleep in wild northern elephant seals. And she is also a graphic designer, science communicator extraordinaire, as you've probably seen over the past few, or the past 2 workshops. She has taught us about using PowerPoint to a much more complex degree than I ever knew how to, as well as Adobe After Effects. And here we are in Autodesk Maya to make our data come alive in 3D animations. So Jessie's science communication work has spanned from 2 children's books to working with the Coastal Resilience Lab here at UC Santa Cruz, and even all the way into the desert to Burning Man. So she has quite a lot of experience under her belt and is generously sharing that experience with us so that we can apply this to our own science and improve our science communication skills. So thank you, Jessie.
Thank you,
Looking forward to learning more.
Thank you for the introduction. So yeah, this is the 3rd part of our workshop. So I kind of wanted to give like a brief overview of what we've learned so far, as well as provide some links to resources. So I've been like hardcore geeking out on data viz podcasts and stuff like that. And learning a lot. So I'm kind of compiling those in these visual posts on my new Instagram page. It's called Art for SciComm. So I'll be giving like a tip a day in December, and then whatever other tutorials you might find useful. I've also just been exploring a lot of the R community, and that's mostly in Twitter because I'm not an expert, but I will be retweeting these amazing data visualization techniques that I'm hoping to learn more about. And then there's obviously the website, which I think most of you have seen by now, but they have all the recordings for the past workshops, as well as downloads to all the materials for each of the workshops. And then if you're interested in learning more about something that I haven't covered, just send me a request and I'll set that up. So the first workshop, we talked about PowerPoint. And that's kind of like the most fun for me because I get to show you a lot of things that you might not have heard about that are probably going to save you a lot of time. And you're all so familiar with PowerPoint. I think it's such an important part of our work as scientists. So we talked a little bit about color design and some tips and tricks, as well as using animations tastefully and also helpfully to display your data and any trends you see. And then I briefly talked about 3D visualization techniques in PowerPoint. Obviously today we're going to be going over like the ultra powerful 3D technique and software Autodesk Maya. And the week after that, we talked about After Effects, and I gave you an introduction to what animation is. Basically a sequence of images that makes a static thing look like it's moving. So we talked about also figuring out what Adobe software to use to make your data visualizations. And then I went over an example linking CSV data to After Effects animations. So then, and I briefly talked about some 3D animation techniques within After Effects, but today we're going to talk about this very advanced 3D animation software, which I do not pretend to be an expert at, but that's fine because it doesn't seem like anyone in this audience is an expert either. So I'm just going to show you sort of the breadth of what's possible in Maya, and then how 3D animation works in general, so that you can see if it's something that's useful for your science communication needs. But I'll be going really slowly, and I'll have these like annoying little icons in the bottom left, so that you can see exactly what keys I'm pressing as we explore this new software. So basically, when make a 3D animation, there's a number of steps. So first, you need to make a 3D model that you're going to bring to life. And that can be as simple as a circle, like a sphere, that bounces on the screen, to as complex as a humpback whale, or even more complex. So Pixar characters that have, I don't know, detailed hair and stuff like that. So there's really some amazing 3D modeling out there. But first you make your model, then you connect it to a rig. So you're basically creating a skeleton for your 3D model, and you're constraining its motion so that it can move its joints. And then you're going to animate those joints over time so that when you watch the animation, you see it come to life. And then you can do various aesthetic additions to that. You can add textures to your surface, whatever it is. So this is me putting a textured surface over the whale model. But you can also add textures that have bumps or some sort of programmed displacement. So we'll actually be looking at putting a displacement map on our ocean surface. So basically you're displacing the surface so that it looks like it has some 3D quality to it. And then you rig up your lights, your cameras, and then finally you render your scene. And the final render can be really complex and beautiful, and it usually takes a long time for your computer to think. But then once you're done rendering, you'll have a series of images, and then you'll compile those images into a movie eventually. So just a disclaimer, people are experts in each of these steps. Like there are modelers who just model for a living, and there are animators who just animate for a living. So it's definitely not simple stuff. So don't feel overwhelmed if it isn't coming very quickly. But I'm just trying to give you the tools so that you can figure out if you're interested in using any of these. So let's go sort of more in depth into each of those steps. So when you get a 3D model to use in your animation, you can either find those online at websites like TurboSquid, Sketchfab, CG Trader. I bought this one online, and then we sort of modified it a bit so that its mouth would open in a certain way. But we didn't want to have to make it from scratch because I know that what I would have made wouldn't have been as pretty as this. And some of them are free, some of them. So there are a number of free models out there, such as the one that I made of this elephant seal. So you can just download those and use them right off the bat. There are some with really nice textures that are free. But if you want the really nice high quality 3D models that come with rigs or skeletons already inside them, and they might come with some pre-programmed animations, those cost a little bit more. So you can decide. You can also make your model from scratch. I think a lot of the, some of the people in this group right now, I think, make 3D models for their research. So if you're already making model tags or model organisms using like Photo Modeler or some other 3D visualization softwares, you can just use those in your animation. I got sidetracked because I thought this was a dollar sign, but it's just H. Okay, so this is a 3D model that I made from scratch. So basically what I did is I used like a rectangular prism, and then I sculpted that to the form of the tag, like the body of the tag. So that's sort of this shape right here. And then I added a cylinder for the video camera. And then these two down here, these are just spheres that I've cut off the bottom to make a suction cup. And then here, I forget, I probably used a cylinder for that. And then for the antenna, I actually created a circle, and then I extruded the circle along a path. So I drew out the shape of the antenna, and then you can extrude along that path. And then this is a 3D model of a fish that I made. So what I did is I downloaded a free model of a fish that didn't look anything like the fish that I wanted. And I just chopped off its dorsal fin and I modified it a little bit so that it looked like the fish that I wanted, because I'm not as good as 3D modeling to actually make it from scratch. But that was really helpful in my case, and I was able to make it look eventually like a sand lance, that is the fish I wanted to model. So I'm just going to open up Maya, and we're going to look at a couple of the modeling tools that are in Maya. So if you open up Maya on your end, you should start, this should be your starting screen. If you don't see something that looks like this, you can go into Windows, Workspaces, and select Maya Classic. So that's sort of just the baseline display. If you are trying to animate, you can go into the animation workspace. That'll show you your graph editor with all of your keyframes. You can also, if you're an expert modeler, then you know all the hotkeys, so you don't need any GUI interfaces. I'm not an expert modeler, so I need some of the GUI interfaces. So I'm going to put it back to Maya Classic. So there's a bunch of different ways to set. So the menus at the top are controlled by what menu set you're in. So right now I'm in the modeling menu set. But if I were to go to the rendering menu set, you can see that all of these menus just changed. So again, there's like these distinct stages of 3D modeling, and each of those has specialized controls. So first we're going to go to modeling, and let's just create a cube to begin with. So I'm just going to go over some of the navigation tools that are really important to familiarize yourself with. So if we want to zoom in on this kind of tiny cube, we can do that by scrolling upwards, and that will zoom into the scene. And we can zoom back out by scrolling down on that mouse key. Then another way to navigate is to rotate around your screen like this. And to do that, you hold down Alt and you left click. So when you hold down Alt and you left click, you're able to sort of gimbal around your screen like this. And if you ever, like me, get lost at some point and I don't know, your object flies to the side and you're very confused, you can just press F and that will frame your object back into the center of the screen. Very helpful. And then in terms of scaling your object, you use the scale tool, which is selected right now, or you can press R to activate the scale tool. You have something in the chat. So all the recordings to the videos will be on the website afterwards. We can post the link in the chat, but just jessiekb.com/resources and password GCSE, very secure. So to scale your object in 3 dimensions, you hover over this center cube, and it's like yellow when it's not selected, and then it turns pink. So you hover over that and you scale it up or down, depending on what you want. If you just want to scale it in one direction, you can just click one of those. So if you wanted to make a really flat rectangle, you'd do that and vertically compress it. Or you can control each dimension. So that's scaling. You can also rotate your object. So this is these are the tools for rotating your object. Each axis is a different color. We'll talk a little bit more in detail about axes in a bit. But basically, if I wanted to rotate it around this axis, I would just click and drag as far as I wanted to rotate it. If you don't like it, Control Z works in this software, thank God. And then if I wanted my object to sort of roll along this axis, I could do that. And so you have all 3 of your axes here. And then this like outer circle is sort of like rotating it from your view. So it's centered on your view. Okay, so now we have really wonky cube. I'm going to delete it. I'm going to actually add a cylinder this time. So we see that the polygons that make up the surface of the cylinder are kind of different. There's this basically ring of triangles, and then each ring of triangles is connected to the ring of triangles on the bottom with these rectangles. So the way, let's talk about just moving really quickly. So the shortcut to get to the move tool is W. If you ever lose track of those shortcuts, you can just hover over it and it'll tell you. So if I want to move the object up or down, I can do it like that. Again, if you select the center, it'll move in all three directions, which is probably a risky thing to do if your views are not locked. But if your views are locked, you can, so right now we're in the perspective view, which allows us to do those cool navigation tools. But if we were to go into an orthographic view like front, we would see our object from the front. And this is really helpful for modeling when you don't want to be accidentally, I can actually show you what happens. So to do that, I'm going to need to explain all of these different selection modes. So basically, you can either select your object altogether, or just an edge, or a vertex face, or face. I don't really use anything except for object mode, edge, face, and vertex. So vertex mode, you're selecting each vertex between your polygons. Face mode, you're selecting faces. Object mode, you're selecting the entire object, and edges, you're just selecting little segments, basically the edge of each face. So I'm going to change my selection mode, and to do that, I right click and hold, and then this menu comes up, and you need to keep your right click held, which sometimes is hard, especially if you're on a trackpad. So I would definitely recommend using a mouse if you're doing any 3D modeling. So if you go to select faces, then you can select each of these faces. And you can do that individually, or you can click and drag. But this is the issue when you don't have your perspective views locked. Basically what it'll do is when I created that square, I not only selected the top face, but I also selected all of these like side faces. So if I were to transform them because I wanted to do some modeling, that would really mess me up. So instead, you want to go to these orthographic views like front to collect all the side faces. And then, I don't know, you could move them to the side, or maybe you want to make like a waist for your object, but you're not controlling the top faces. So, or if you wanted to go to the top view, zoom in, and you can select at this point all of these faces, and then if you go back to perspective, you won't have selected any of the sides. So just be really careful when you're selecting things for modeling. And then what other tools are there? There's Extrude and Sculpt. So let me, oops, there's a face left over. Orphan face. And sometimes Maya just confuses me. So I'm just going to delete it from there. Okay, so if I wanted to create a cube, and in order to model this, I kind of want to change its complexity a little bit. So there should be a way to change the number of subdivisions. Material attributes. Okay, so yeah, so there's only one subdivision here. And if I want to change the complexity of my object, I can increase the number of subdivisions. The more subdivisions you add, the more complex your shape becomes, the more vertices you have to control, and the longer it will take to render eventually. So if you have like, I don't know, 1,000 subdivisions, you'll have a really detailed shape, but it may take a really long time to render. So we're just gonna put this to 10 right now in all 3 directions. So pretty much everything has 3 features in a 3D modeling software. Okay, so we've done that. And for this, I want to go into, let's say, edge mode. And what I'm going to do is I'm going to select all of these edges, and then I'm going to apply, like right now, the edge is really sharp, right? So if I wanted to radius that edge, because maybe it's a tag that we're putting on an animal and we don't want it to hurt the animal, so you can actually radius that edge. And I know. Sorry, not getting it to work. I don't know why it's not working. Let me see. Okay, so there, I just got it to bevel. So right now, there's going to be a slight bevel to that edge. It's not super pretty because I didn't do a very careful job of selecting what I wanted it to bevel, but that's the general concept. So actually, let's do it just with a simpler object like this. And for this, then we can select an edge and just bevel that edge, and we want to increase the segments, so then we get a nice rounded curve. Basically, you'll be able to sculpt the object more specifically. That's kind of what I was doing with the fish earlier. So you can do that if you're really into modeling. Sorry, I talked to Siri by accident. If you're really into modeling, you can do this crazy stuff, sculpting in 3D in virtual reality. And my friend makes art like this, so he kind of just like draws, and I don't know. It's just to show you that there's a wide variety of skills out there and also tools to do that. So depending on how into 3D modeling you get, maybe you'll enter the 3D realm. So I think it's pretty cool when they sort of start building the design. You can kind of see it's like exactly like they're sculpting a clay model. Pretty wild. Anyway, wild. Okay, so rigging is basically where you create a joint for each of your, for each place where you want rotation to happen, and then constrain by adding basically bones where you don't want any rotation to happen. So for this example with my fish, I made a super simple skeleton because that's all I could handle. And I made just a bunch of joints down the body. And then basically each of those spherical joints, you can add a control to, and then this is what a control looks like. So you can basically fix it to a circle, and then you just have to move the circle instead of actually moving the skeleton, which can be dangerous if you move the skeleton in the wrong place. So with our whale, my brother helped me rig up these controls with each of the joints of the whale, so that you can sort of move the tail more easily without having to go inside the mesh each time and manipulate those skeletons. Okay, and then to animate, that's when you start adding keyframes to each of those controls. So you're basically locking the controls into position at various times in your animation. So for so this is kind of what my brother helped me do with the whale. And then this is me alone doing a very simple version of that, basically just making this fish swim back and forth. So just moving the controls back and forth in a swim cycle. So you can control these animation keyframes in the graph editor. And that's sort of what's in the tutorial at the end of this workshop. So I think what I'm probably going to do is I'm going to go over as much as I can in the hour, and then you're free to sort of learn on your own and explore on your own after that. So then you can add a texture to your 3D model. So this is actually one of my favorite parts because I'm actually not that bad at drawing, but I can't really conceptualize some of the 3D modeling stuff. It's really hard for me. But so what you can do is you can have your 3D model and you can export basically like a smushed flat version of it. So if you were to think of your model as like a piece of origami, and then you just unfold your origami, like if you were to have a cube, it would just be 6 squares flat on a piece of paper. So you're basically creating a flat version of your 3D model. And in this case, the right size of fish, I wanted to be identical to the left. So you can paint them both at the same time on this UV texture. So you basically export that flat squished version of your 3D model, and then you can bring it into programs like Procreate. This is the one I was using here. And you can just draw on like the grid lines help tell you, so this is in the shape of the free model that I use. You can see it doesn't look exactly like my fish over here, but it's good enough that I, mooch off of their hard work to know where the fish eye is and all of that stuff, which can get complicated when you're compressing a 3D model into 2D space. So then you apply the texture by basically assigning a material to your model, and then it just puts that 2D texture on top of your 3D model. And I didn't have to do a really good job of this one because these fish are like that big compared to the whale that's huge. But that's generally how that works. And then this is a more complex example. This is the texture that came with our more expensive $129 model, which I really like the watercolor, or whatever the effect that you use here. I think it looks really good. So that's just an example. So you see, like, there's the tongue, there's the baleen right here, there's the eyes, or at least the area around the eye, and then this is the eyeball. So pretty complex. And then this is the fluke pattern. All right, so I'm just gonna slowly move into the tutorial, and we'll sort of follow it until we can, and then we'll make sure to wrap up at the end in case there are any questions. So I think for somebody who's asking how are these UV patterns made, there are some softwares sort of similar to the Oculus Medium sculpture that we saw earlier that make this really easy for 3D artists. So they can basically paint on their models with pretty high precision, and so you can either do it like that, so you see sort of your texture in context with the animal, and I suspect that they probably use this software sort of like that. I forget the names of the softwares for these, but you can basically find software where you can paint it on the 3D model, or you could just try to paint it in 2D and then superpose it on this 3D model afterwards. But again, that's pretty tricky in some cases with more complex models. Okay, so if you downloaded the materials from the workshop, you should have access to this OBJ file. You can also find it online on Sketchfab. So that's just a free model that I made based on another free model and modified it to look more like an elephant seal, which is what I study. And then you can organize those files into your Maya folder. So basically, I think it's always good when you're learning a new program to understand how you should store your files. So by default, when you download Maya, you have a documents folder, and Maya folder goes in that documents folder. And then within Maya, you go to your projects folder, and then there's a default project folder that we're going to be working with, just because we don't need to be super organized about it. And we're going to put things into this default project folder. Yeah, so all of this 3D modeling and animation is pretty similar across platforms. I use Maya because it was something that my brother was more familiar with, but Blender is really great because it's open source and there's a huge community of people creating materials. But all of the same terms apply for Blender, and I think that's really the most important thing with digital software is knowing what terms to Google. So all of these concepts like applying textures and all of those things will be the same in any 3D animation software. So yeah, so once you have your 3D model, you put it into your assets folder, and that's kind of where we'll keep track of all of our objects. And then once you have that, you can import it into Maya. So I'll just go sculpting it. You're going to go and import your elephant seals model into Maya, and it'll come in. It'll come in at a certain size that's determined on when I modeled it. I made it a certain size. So we're gonna, once we put our data in, we'll sort of reassess how well it fits into the scene. So now we have that in there. That worked. We're going to rename our model. So we can do that by selecting it. You can either do it here, similar to most renaming. You can just press enter and then type in the new name. You could have also done that up here in the attributes editor. We're going to delete whatever's left of our cubes. So now we have our seal. And so this is where I save your scene. So we're going to save our scene, and we're going to put it in this default projects Maya folder, which you can see I have a lot of scenes in here, but you probably don't have as many scenes. That's okay. So just write it, and then there's two file type options. I usually use Maya binary. Don't think it really matters for our purposes. It's kind of basic uses. And then we're going to open the script editor. So it is hiding inside your windows. This is sort of how you get to all of the different editors. It's under Windows, and your script editor is under General Editors. So by default, I have a version of this script that I actually, it's not exactly like the script that y'all have, because it has a couple more columns to fit the data that comes off of CATS tags, which is one of the types of tags that the humpback whale researchers use. So in this case, it's a little bit more involved, but I'm going to add, I'm going to just open our script, which is, again, a simpler version. Maybe I forgot to put into here. So it's called seal sample data. Let me get it. Should be in here. Oh, maybe, okay. Interesting. Oh, there it is. I was in the wrong folder somehow. So we just opened that sample script, and I'll go over that script. So we're basically telling Maya that we want to import a CSV. We need to use this PyMel core thing. I don't exactly know exactly what it does, but it's something that Maya needs to run the Python script. And we're just going to run it right now because it takes like a couple seconds to do that. So basically what we just ran, this is just defining our variables based on our headers. If you don't know what your headers are named, they're in a separate data file, just because I didn't want to deal with whether or not the headers were included in the CSV. So the CSV is saved without headers, and the headers are here. So this is just defining, my first column is, again, 0, just like in JavaScript. And then 1, 2, 3, 4, 5, 6. So they're all named like that. I'm defining 2 more variables, a start variable and an end variable, which is just the seconds that I want to animate. So if you were only interested in seconds 40 to 80 of your accelerometer data or whatever data you're dealing with, then you could put in different values there. But for my fake data, which I manufactured kind of clumsily, I'll explain exactly what format that's in, or sorry, what the animal is doing or what I would expect it to be doing. I just wanted to put in some values that I was really sure what the animal is doing, because sometimes it's hard to know unless you know your data really well what an animal is doing at a certain time to make sure that it's input properly. This is just defining your sample frequency. So in my case, my data is sampled at 10 Hertz, 10 times per second. And then you open your CSV file. So this is probably one of the only parts that you'll have to modify on your end. Just make sure that's updated for you. And then make a new variable called data, where you read in your CSV file. And then you go through this for loop that goes through all of the rows in your data file. It'll print what row you're on just to help you keep track of where it gets stuck. And then if the data is between your start and end indices, then you will actually animate that data. So to animate the data, first we need to get the time in your data equivalent, or find the equivalent with the time in Maya. So the time in Maya is in seconds. So we basically transform the time from whatever it is in currently, which is in 10 Hertz, into time with, in terms of time in seconds in 24 frames per second. And then we're going to import our data into these values. So in Python, you import these values using float, which is a function which returns a floating point number. And you're going to do that with your data for the X position and the Z position. I'll talk a little bit about axes, it's kind of confusing. But you might need to do some manipulation with how your data is saved and then how the axis orientation in Maya. So just make sure you have something that you're pretty sure how it's going to come out, so you can make sure that it's visualizing correctly. And then you define which object you'd like to transform. So we named ours elephant seal, so it's going to transform that object. And then we use the set key function to set keyframes at each time value in our data. transformed again using this. So by deleting the start time, you basically say, even if we're looking at seconds 40 to 80 of our data, we want it to start at second 0 of our animation. So you're setting the value, the X position value at that time. So you're setting keys for all these translate values, and then you're also setting keys for your pitch, roll, and heading, which define how you're rotated in 3 dimensions. So before we look at whether or not that worked, I want to talk a little bit about axes in Maya and in your data. So typically, your accelerometer axes, there's the vertical axis is called Z, and in Maya, it's actually called Y. And I don't really know why, but you can change this if you want in Maya, but it's something to keep in mind, especially if you're just opening it up and then putting in your data. So just make sure you understand what positive direction is what, and Maya has just a little tiny indicator of what the axes are, and so each of the parts of the axis that are indicated here are the positive directions of that axis. But so I'm not even going to talk about the letters because honestly they confuse me. I just want to know what my animal is doing, and I want to make sure that that's correct, right? So instead we can just use the words pitch, roll, and heading and make sure those are accurate. So when an animal is pitched up, that means that its pitch is positive, and you're basically holding on to that x-axis or whatever it's called, and you're rotating it 45 degrees upward. So it's like a shish kebab. Your elephant seal's on a shish kebab, and you're just rotating it a little bit. And then you can rotate it downward. That's a pitch of negative 45 degrees. And then when we talk about roll, we're talking about rotation around this other axis. Again, Y or Z, depending on what software you're in, but rolling is pretty self-explanatory. It's basically changing from being prone to supine. And then heading, so this is 180% rolled. My elephant seals often spend a lot of time in this position when they're asleep. And then heading is when they change position around that vertical axis, either Y or Z, whatever your axis conventions are. So this is actually a turn negative 45 degrees. I had to think a little bit about the right hand rule yesterday, but basically your positive axis direction defined by the right hand rule. Okay, so now that we know what those axes are, let's look at the sample data that I gave you. So in the sample data, we have our seconds in 10 Hertz increments. And then we have our pitch. So it starts out at negative 40. So the animal, we're expecting it to be pitched downward, right? And then in this second segment, we're going to have the animal come back to a 0 pitch. So we're expecting that the animal is going to be doing that until this section. So it'll be when it's at the surface where its depth is 0 all the way to negative 40 degrees. We're expecting that the pitch will be negative 40, and then it'll even out when it goes to the bottom. And then just to make sure, again, our data is working correctly, I have it rolling from its prone position all the way to its supine position when it gets to the bottom at 40 meters. So let's see if that works for us. I actually, based on the way that I saved my elephant seal file, had to add a negative and also delete a negative here. So let's make those 2 changes. So I'm just going to delete this negative sign, and I'm going to add it back at pitch value. So again, you might have to slightly modify the code depending on your data and also your model and what axis conventions it was saved in. So sometimes it doesn't, oh, there we go, it updated. So now we can see that our elephant seal is actually traveling in 3 dimensions along the track of its data. And then when it gets to the very bottom, does it roll? Let's see, sorry, I need to move people's faces away. So when it gets to the bottom, what does it do? Well, we can't see all the way to 286 frames right now. So we need to extend the duration of our animation by dragging there, or you can change this to be 286 to show the very end of your animation. So now we see all of the frames, so we can kind of scroll through all the way to the end where it turns upside down. So this shows us that we've been able to import our data correctly, which is great. So next, we can preview that animation. Your data may come in a little bit choppy if you're dealing with like raw, really high resolution sampled data off of your tag. So if you go to your animation workspace, then you'll have this graph editor come up where you can actually see your data. And this is kind of cool because you could also choose to plot this data in After Effects or even in Maya if you wanted to. So what I'm going to do is, since I made these artificial, like really simple changes in slope between like 1 and 0.5 or whatever. So I'm going to simplify these curves because I don't need like 120 dots because I'm really modeling something pretty simple. So the way that I'm navigating in this window is you hold down Alt and then you middle mouse click and drag to pan. You can scroll in, scroll out, and Alt click does nothing. So I want to simplify these curves. So I'm going to select all of my keyframes, and then I'm going to simplify curves. I want to open the menu. So I'm going to open that menu, and I'm going to I'm going to use the default settings. It's set to deal with dense data, which seems like that applies to me. And I could always mess with these settings if they're not working for me. But that's kind of good, I think. It's like basically just simplifying. It's basically saying, hey, Jesse, why did you use so many points? You're really just changing it like, I don't know, 5 or 6 times. So that's really helpful in smoothing out your motion. And you can do that with much choppier data as well. So now I've done that. I seem to have lost my elephant seal, so I'm going to press F to bring him back. And then I've gone over this. And then you can export a quick low resolution Playblast of your animation by going to Windows and Playblast. Right now, it's going to do it from that perspective view that I just used. So I know that it's only going to be in view for like a second, but that's okay. So now we can just really quickly preview our scene, which is important, especially when you have like a really complex scene, like you all will have later once you add the ocean and everything. You're going to want to make sure that you have a simple enough scene that it will render quickly. So if you do Windows Playblast, now this time it should be in frame for the whole time. So you can see this really low resolution preview of my animation. And it slowly rolls. And the way that the Playblasts work by default is that they don't actually save. So if you want to save your Playblasts to use them for whatever reason, you can. And if you open that menu, it'll give you some options. So I think, yeah, right now I did set it to save. Oh, no, I didn't. So it's just a temporary file. But if I wanted to save it, I could save it there. Okay, we have that. So if we want to really look at what size this elephant seal is in relation to its scene, we'd see that if this is 40 meters, this elephant seal is probably too big. And we can figure out exactly how big he is using rulers and tools. But I'm just going to take the easy way out here, and I'm going to go back to my my classic view, and I'm going to go to the elephant seal properties, and I'm going to change in the attribute editor to scale him to basically half of his size. Make sure to do that in all 3 dimensions, or else you'll have a really wonky looking seal. And then you can add a simple texture. So I don't actually have like a really high resolution texture for this elephant seal yet, but I think I'm going to make one soon. So you can add that texture. You can zoom into elephant seal, and you can add a new material. Or you can add a favorite material to do that more quickly, and just add a Lambert. That's kind of like a simple, not too shiny shader. So now we have that applied. I'm going to rotate in a little bit. And then we can add whatever color we want. So I can make him like ogre green or something. This is how you select the colors. So I'm going to try to choose like a light brown or something. Maybe a little bit more grayish. So now I have a color for my elephant seal. Obviously, it doesn't look very good. You could probably do a much better job with if you were to export the UVs and then really paint it on. But that's fine for our purposes right now. And then we're going to add some water. So to do that, we want to, let's just go to the beginning of the animation when the elephant seal is at the water surface. And we're going to add a plane. So we just click on the plane and we change its properties. We're going to make it really big, 500 by 500 by 500. So now we have a plane for our water. And we are going to see what it all looks like, because if we want to make an animation, we're eventually going to want to render it. So let's open up the render preview by going to the Arnold menu. It's actually showing up in the modeling menu because that's also kind of like when you want to see what things look like. So you can go to Open Arnold Render View. And then this will, I really like this tool because it gives you like a live preview of what your rendered image is going to look like. You can also render the frame, but that often takes a lot of time and it's pretty slow. So if we render our scene right now, we see absolutely nothing. That's because we have no light in our scene. So we're going to need to add a light. So we're going to go to in the Arnold. We're going to choose an Arnold light, and we're going to put a sky dome. So now we have a sky dome, and we all of a sudden see our elephant seal's butt going into the water. So this sky dome by default is just white, so that's not very pretty. So in order to change what color it is, we can go to its attributes, and we can either change just like the whole sky dome at once and just make it blue. That's simple, but we could also link it to a more complex texture. So we could add a file and add like an HDR image of a sky to add some clouds. But we could also add, what I usually do is just add a color ramp. So this is basically adding a gradient to your sky dome. So we want to add some like dark blues. If you want to add a new one, you just click again. And then we want to add some light blues near the surface, maybe like a little bit of light blue in the middle, and then a little darker, maybe not that dark, it's a little extreme. You can waste a lot of time on this. and I definitely have, but I don't know, just do something that looks good. Usually you want a little bit of blue at the top, and then I like to make like a fake sun just by adding a little white at the top. So basically, if we were to look, so right now we're under the ocean, but if we come above the ocean, we can see that our sky, I feel like I'm often moving my head to see around in 3D space. It doesn't work. So anyway, if we look at our sky, we see this like white sun. That's kind of like a simple way of having a sun effect. So now you have your sky dome with all of those blue things. And we have this kind of ugly ocean surface, right? So yeah, I want to be mindful of everyone's time. And if you want to head out, or if you have any questions right now, we can take like a little bit of a break to chat. I'll probably finish up the tutorial for anybody who wants to see the end, if there's enough interest. But yeah, are there any questions?
Could you do the sky dome again?
Yeah, so do you want me to just put it, like put it in and everything? Or just the colors? What part of it?
Or both, adding the skylight and then adding the sky color to it, I guess.
Okay. All right, so basically what you can do is if you wanted to see what the scene would look like without your sky dome, you can press Control and H to hide your sky dome, and then we could add in a new one. So to add it in, we just click the sky dome icon right here. Sometimes, depending on how zoomed in you are, you'll like, I'm dealing with some really big scenes in that humpback whale animation. So sometimes I have to make my sky dome like bigger or smaller. So if you needed to do that, you could always scale it just like you scale any other thing. So now you have your sky dome, and to add the color, you can either just click here to add like a solid color, which is fine, or if you wanted to add either a file or a color ramp, which is what I did. So you just add that color ramp, and then you select your colors. I mean, won't make you watch that whole thing again, but that's how that works. So you select basically each of these color nodes, and then you change the color of each of those nodes. Okay, so let's show our sky dome again, and we can hide that one that we just made. I don't know, I guess if it works together, it just does kind of like an average of the two. Interesting. Okay, so now we have our sky and our ocean, but our ocean still doesn't look very good, right? So we're gonna make it look interesting by adding an ocean texture first. So there's two different ways to do this. You can either go and assign a new material and then click the Arnold standard surface shader, or you can go into the Hypershade editor, which is this thing that looks like an egg, kind of like a hard-boiled egg. Open it up, and you can create a new texture here. So if we go into Arnold surface shader, and we click the Arnold standard surface shader, that'll add into our node editor this this new standard surface shader. And the Arnold surface shader is nice because it has a lot of controls compared to just the Lambert or the Phong or whatever other shader you're using. So we have all of these controls. We're actually going to change its transmission to 1 to make it completely transparent. And once we've done that, we're also going to change its name to Ocean Shader, Ocean Surface. so that we remember what it's referring to. So you can apply this to your ocean surface just by selecting it with your middle mouse button and then just dropping it onto the ocean surface. So you can see it's transparent in our scene, which is a little confusing, but you can see that it's here bouncing some of that sky dome light upwards. Okay, so now we're going to add a displacement map. So we're going to go here and we're going to add a displacement material and basically connect that node to a file. And we're going to upload a file here. And we just click that little folder icon to add our file. And it's in the images folder, ocean texture images, and just click on the first file. And then you can open that file to link it. And you can see how it started to look really crazy over there, right? So that's partially because it's super big right now, and we want to make it smaller. So to do that, remember, we want to repeat the UV in 2 directions. So we have our 2D surface looking a little bit better there. And then the other thing that's an issue here is that it's connected right now to displace whenever it's black or white. So it's, or black or transparent because it's connected to this out alpha. So it's basically determining the displacement based on the transparency of that layer. And instead we want to connect vector displacement to out color so that it basically displaces the surface of the water based on the color of that pattern. So we do that. And then we should be able to see our new link. Good, we did all of that. And then we also want to add a loop to this texture. So we want to loop through. So to do that, we have to go into the attribute editor. We have to get out of this. We want to use image sequence. And then we want to loop through all of our 120 oceany frames. And I always forget the code that I have to put in here. So I just copied it into here. And then I will paste it into here and press edit to upload. So that'll make sure that basically it's using an image sequence, so it'll update each frame to the next pattern. And then in addition to that, after 120 frames, it'll loop back to the beginning because our animation is 286 frames. So we want to make sure that the pattern keeps moving over time. So then basically you're done, or at least you're done compared to this set your done point. So you basically just render your scene. And then once you've rendered it according to these settings, you'll come up with a bunch of pictures. And then you can add those pictures to After Effects, and you can export a video. And then your video will look something like this. So you'll have a moving ocean texture, and you'll also have your 3D model moving according to your data. So that's it. Yeah.